Hey everybody, Mr. Zamora here. What we're going to do today is talk a little bit about introduction to integration. Now, this is a basic calculus term that you're pretty much going to be using in your calculus class, and also if you took a college calculus class, and also a little bit in statistics as well, you're going to be using this concept. But before you know any concept, you have to be introduced to it, and that is the purpose of this video. So, integration introduction. So, this is actually the integral sign. It kind of looks like a fancy looking S, or if you like music, it kind of looks like a little treble clef almost. I am not a music person myself. That is the only thing I know. This is a math channel after all, not a music channel. But anyways, so this is the basic formula for an integration. So this is the integral sign of x raised to the n power times dx. And that equals 1 over n, which is the power of x, plus 1 times x raised to the n plus 1, which is the power. And then whenever you have an integral that doesn't have values at the top and the bottom, you're going to do plus c, which represents the constant in this case. We're only going to be going through indefinite integrals, meaning integrals that don't have certain values to them. Later on in another video, I'm going to show you how to do integration of definite integrals where there was like a 4 up here, or like a -3 or something like that. So with that equation out of the way, let's do the first example here. So we have to integrate x squared dx. Well, first, before we do that, let's try to identify the parts here. So we know that x, this is just going to be the regular variable, so I'm just going to label that here. Now we have to look for the n value in this case. Now the n value is actually going to be the exponent. So we know that the exponent here is going to be 2. So I'm going to say n equals 2 in this case. And now that we have that information, we can actually integrate it using this equation right here. So let's try this out. So we have 1 over, well, we know that the n value is 2, so that's going to be 2 plus 1. And then I'm going to multiply that by x. The x does not change, unless it, of course, it was a definite integral, then we would actually have to plug these values in. But like I said, I'll do that in another video, maybe at a later time. So we have to raise it to the n plus 1. Well, we know that n is equal to 2, so that's going to be 2 plus 1, and then plus c. Now let's try to clean this value up here. So this 1 in the numerator is going to stay the same, and 2 plus 1 is going to give us 3. And then x raised to the 2 plus 1 power is going to give us another 3. So that can be 1/3 x cubed, and then this constant actually stays the same here. Now when you do other integration parts that deal with position, velocity, and acceleration, the c is actually going to have a certain value to it, but since this is an intro, I'm not actually going to go over that. I'm going to go on that in maybe a different video. Okay, so we figured that out, and let's go to number 2 here. So it's asking us to integrate 4x cubed plus 7 times dx. Okay, so let's try to label everything here. So we know that the x value, that's a variable. And we know that the n value right here is going to be 3. So let's integrate this like normal. Now, whenever you have a subtraction or an addition right here, it's actually like you're integrating 2 of these. So it's like I'm integrating this part, and then I'm going to add it to that integral right here. So if you wanted to, you could split it up and be 4x cubed plus, I'm going to write a dx here, plus 7 dx. Now you could do that. Now this is for like a basic intro, but once you start integrating more and more, you won't actually have to do this. But it is always good to start off if you're learning the introduction. So let's actually, I'm going to push this 4 aside right here. I'm going to use that a little later. So it's going to be 1 over, now the n value we know is 3, so that's going to be 3 plus 1 times x. And like I said, we know the n value is 3, so that's going to be 3 plus 1 plus c here. Now, I have this 4 outside here because we're actually going to distribute that a little bit later on, which is what I'm going to do right now. So 4 times 1 over 4 times x to the 4th plus c. So what I'm actually going to do is that you can distribute this 4 here, and what happens is that you get 4 over 4 x to the 4th power, and we know that 4 divided by 4 is actually just going to give us 1, so in that case I'm just going to cancel it out. So we have x to the 4th right here. So we figured out this first part, now let's figure out this part. Now, unlike taking a derivative of any constant that's going to give you 0, when you have to integrate, an integration is also called the antiderivative, meaning that you're going to add an exponent to it. So this is technically x to the 0 power, So in that case, whenever you integrate a constant, you're only just going to add an x to it. So that's going to be plus 7x. And then, of course, we have the plus c, and this is a indefinite integral. Okay? And like I said earlier, when you integrate a constant, you're just going to add an x to it. So in this case, I have right here just an integral of 8 times dx. Now, if you wanted to, you can raise it to the 0 power, and if that's the case, you can say n is equal to 0, and you would get, using the equation, you would get 1 over 0 plus 1, x raised to the 0 plus 1, plus c. This is actually where it comes from if you were to use the equation. So that would be 1 plus 1 times x raised to the first plus c. Well, we're always integrating this h right here, so that's just going to be 1 over 1, 8x plus c. Now we know that 1 over 1, this is technically imaginable, so we can just cross that out. So if that's the case, we get 8x plus c. And we are all finished here. So this is just a basic intro to integration for those of you who want to learn calculus or just want to learn how to integrate to brag to your friends or whatever, or claim that you're a mathematical nerd much like myself. But with that out of the way, I hope you enjoyed this video. There will be more coming soon in terms of integrating indefinite and more definite integrals, and maybe I'll do some position, velocity, acceleration videos in the future. But with that out of the way, thank you for watching, and I shall see you soon.